The next video in the motion unit is on momentum. First thing we want to do here is we want to look at how we define momentum. And before we give an actual definition, I just have a couple of questions I want you to consider. Which is harder to stop? A baseball traveling at 10 miles per hour or a car traveling at 10 miles per hour? So envision you're say standing somewhere and there's a baseball coming at you at 10 miles per hour. How would you stop it? Well, you'd probably just reach your hand up and catch the thing. That 10 miles per hour is not very fast. You would easily be able to stop the baseball by catching it. Now, if there was a car traveling at you at 10 miles per hour, let's say the car is in neutral, so the gas is not being pressed, but neither are the brakes. If it's just rolling at you 10 miles per hour, you're not just going to be able to stick your hands out and stop the thing. Maybe if it's a fairly small car, you might be able to get it to slow down and eventually stop without it running you over. I would not recommend trying that, though. That could be very hazardous to your health. But the point is this, is the car is much more difficult to stop, even though it has the same velocity as the baseball. They're both going 10 miles per hour. Second question I want you to consider. Which is harder to stop? A baseball traveling at 10 miles per hour or a baseball traveling at 110 miles per hour? Well, the answer there is obviously the baseball going at 110 miles per hour. The one that's only going 10 miles per hour, you could easily just catch, as we said before. If it's going 110 miles per hour, if you're not wearing a baseball glove, you try to just catch that thing, you'll probably stop it, but it's going to break some bones, very likely, in your hand, I would say. And I would say it'd be more likely than not that you'd end up with some injury of some sort, maybe not a broken bone, but certainly some bruising and some swelling and whatnot, because that would be very fast. So even though the two baseballs are the same mass, because they're both baseballs, the one that's going faster is harder to stop. So we have this idea now that there are two factors that determine how hard it is to stop an object. Or in other words, two factors that determine an object's momentum. Those two factors are mass and velocity. So a more massive object has more momentum. An object with a greater velocity has more momentum. Now consider this. How do you think we calculate momentum? What do you think we do mathematically to those factors, mass and velocity? Well, the answer to that is we multiply them. The momentum of an object is equal to an object's mass, as you can see here, times its velocity. If we were to turn that equation into symbols, it would look like this, where we use m and v to represent mass and velocity, respectively. And then this is a little odd, but the symbol we use for momentum is a p. So p equals m times v. That means momentum equals mass times velocity. If we were to turn that equation into a t helper, it would look like this. And recall, this is not something you need to memorize. This will be given to you on any quiz or assessment that you might have. So you don't need to memorize it. What you do need to know, though, is you do need to know which symbols apply to which quantities. So you need to know that p is momentum, m is mass, and v is velocity. All right, so this finally leads us to a definition for momentum. Now, in all my years of teaching science, I've never really seen a great definition for momentum. This is one that I've kind of developed over the years because I think it just makes sense with how we think about momentum. The momentum of an object is simply the measurement of the energy required to stop a moving object. So the greater its momentum, the more energy it takes to stop it. Let's look at how we calculate momentum. Let's look at some examples here. So the first one, a 10 kilogram dumbbell is falling at a rate of 6.5 meters per second. Determine the momentum of the dumbbell. So here's our equation helper from the previous slide. And recall the symbols there. P is momentum, m is mass, v is velocity. So the first thing we want to do, as always, whenever we have a calculation, we want to write the equation for that calculation. And here we're asked to find momentum. So remember, we want to cover up momentum in the equation helper. Notice we're left with mass and velocity. They're next to each other. So we're going to multiply. So momentum equals mass times velocity. At this point, we're going to plug in numbers. So we're told we have a 10 kilogram dumbbell. And note that kilogram, that's a unit of mass. Okay, how much matter is in something. And then meters per second is a unit of velocity, so we'll use that for a velocity. So plugging in our numbers, we have the momentum equals 10 kilograms times 6.5 meters per second. Now, before you worry about getting an answer here, I want you to consider the units to this answer. Notice I have kilograms for 1 unit, and I'm multiplying that by meters per second. You might be thinking, but wait, nothing's going to cancel. I can't really convert the units so that they match up and cancel. And you're absolutely right, they won't. Whenever we multiply these two units, kilograms times meters per second, what we'll have for our unit is simply kilogram meter per second. So our answer, if I take 10 times 6.5, that'll be 65. So my answer is the momentum equals 65 kilogram meter per second. That's exactly how I write the unit there. Kilogram meter, meaning I'm multiplying kilograms and meters, and I'm dividing by seconds because I'm dividing the meters by seconds up here in the meters per second anyway. So that's the unit for a momentum, or at least it's a unit. It wouldn't have to be the only unit, but it is certainly an appropriate unit for momentum. Let's look at another problem. It says, find the momentum of a baseball, mass equal to 265 grams, traveling at 50 meters per second. So now, again, like before, I'm asked to find momentum, so my equation will be the same. Momentum equals mass times velocity. From here, we can plug in the values for the quantities, the mass and velocity. If I look back at the problem here, I can see we're given the mass of 265 grams. Now, you will notice that this is a different mass unit than we were given before. In the previous problem, our mass unit was in kilograms. But anything with the unit gram in it, whether it be gram or kilogram or milligram, those are all units of mass. And then we're told that it's traveling at 50 meters per second here. So that would be our velocity. So plugging in those values, we get 265 grams times 50 meters per second. And again, consider the units as you did before. Notice none of the units are going to cancel, and that is the case with momentum. Notice we will, in this case, we'll have grams times meters per second instead of kilogram meter per second. And we get a momentum of 13,250 gram meter per second. Now, if I were to ask you to compare the momentums, or I guess momenta would be the plural for that, between problem 1 up here and problem 2, you could not compare them directly because notice they do have different units. Kilogram meter per second compared to a gram meter per second. If you wanted to compare them and say which one was greater, you would need to change one of them. You would either need to change this one down here into kilogram meter per second or the one up top here to gram meter per second in order to compare them directly. All right, let's look at a different situation here. And in this case, I'm actually not going to ask you to calculate anything, but just to consider a situation. And the question is this: which would have the greater momentum? A loaded 18-wheel semi-truck traveling at 5 miles per hour or a golf ball traveling at 125 miles per hour? And I want you to explain your answer. So go ahead and pause the video, think about that, and see what you can come up with. So you've had a chance to think about it. And again, refreshing our scenario here, we're asked about which one would have the greater momentum. We know that momentum is mass times velocity. And we also know that anything that if we increase the mass, it would have a greater momentum. If we increase the velocity, it would have a greater momentum. So what we're weighing here is the difference between the semi-truck and the golf ball. We're told that the semi-truck is only going 5 miles per hour, but the golf ball is going 125 miles per hour. So your initial thought might be that the golf ball would have a greater momentum because it is traveling so much faster. However, it is actually not. It's actually the semi-trailer. The semi would have the much larger momentum. And this is because even though it's traveling much slower than the golf ball, in fact, if you do the math, if you take 125 divided by 5, you'll see that it's actually going 25 times slower to be exact. That loaded semi-trailer is much, much, much more massive than the golf ball, meaning simply it has more mass. If you consider it this way, because we said the golf ball is traveling 25 times faster, if you think about it, if I had 25 golf balls, would that equal the mass of one loaded semi-trailer? And the answer is no, of course not. It wouldn't be anywhere close. The mass of 25 golf balls would not be anywhere close to the mass of even an empty semi-trailer. So that extra velocity for the golf ball would come nowhere close to making up for the fact that it is way, way, way smaller than the semi-trailer. So the semi-trailer would, in fact, have a much greater momentum. Even without calculating it, we could make that determination just using some logic as we have there. All right, let's look at some other calculations that involve momentum. First calculation, determine the mass of a bowling ball. So notice right there, we're asked to find the mass, not the momentum. So determine the mass of a bowling ball if it has a momentum of 50 kilogram meter per second while traveling at 10 meters per second. So here's our equation helper that we've seen already. And as we just mentioned, in this problem, we're not asked to find momentum. We're actually given the momentum. We're straight up told the momentum of this bowling ball is 50 kilogram meter per second. We were asked to find the mass, so we need an equation for mass. Well, covering mass up on our equation helper, you can see we're left with momentum over velocity, so we divide. So the mass of the bowling ball will be its momentum divided by its velocity. At this point, we can plug in some values. We're told the momentum is 50 kilogram meter per second, and the velocity is 10 meters per second. So notice here we have 50 kilogram meter per second divided by 10 meters per second. Take a look at your units here. Ask yourself if any units will cancel. And if you take a look at the meters per second, you'll notice that meters per second appears in both the numerator and the denominator. So meters per second will cancel, and that would leave us with kilograms, which that would make sense for a mass unit of kilograms. So we plug it into our calculator, 50 divided by 10, or obviously you can just do that in your head. That would give you 5 kilograms for the mass of the bowling ball. All right, last question here. How fast is a car traveling? So right there, how fast is it traveling? I know I'm being asked about a velocity or a speed. So how fast is a car traveling if it has a momentum of 7,500 kilogram meter per second and a mass of 800 kilograms? So like before, we're not asked to calculate momentum. We're asked to find velocity. So I'm going to cover up velocity, and notice I'm left with momentum divided by mass. So I'm going to plug that in. Here I have velocity equals momentum over mass. And then we're given both of those values. We're given both momentum and we're given mass, so I can plug them in. My momentum is 7,500 kilogram meter per second divided by the 800 kilograms. And notice here my units that cancel are kilograms because one appears in the numerator, one appears in the denominator. So those cancel and I will be left with meters per second, which would make sense for a velocity. I plug that in my calculator and I will get 9.4 meters per second. So this ends the short lesson here on momentum. You will have a chance to practice this in class, different problems if you have not already. And you'll see momentum applied in several different situations, both quantitatively, meaning with numbers, and qualitatively, meaning without, more observation type situations.